Good morning, grade 11. Welcome back. And today we're going to start the first session in the second quarter, inshallah. We hope it's going to be easy, inshallah, and better than the first quarter. So today, inshallah, we're going to start in chapter 6, section 1, introduction to chemical bonding. So as we studied in the first quarter, we know that atom in normal situation always try to be like a noble gas. They want to be stable, so they start to go through a chemical reaction. They start to lose, gain, or even share electrons that try to fill their outermost energy level to be stable like the noble gases. So that's why we can't find atoms free in nature, or most elements in nature they are already found as a particles of molecules, or they are already found in compounds. So for example, the oxygen is O2, so which means two oxygen atoms are combined together. Nitrogen N2, which means two nitrogen atoms combined together. Water H2O, that means two hydrogen atoms and one oxygen atom, they are combined together. So that means in nature it's very hardly to find a pure element, or that's pure atoms of an element in the nature. So always we find the atom are combined with similar atoms or different atoms, okay, that's to be stable. So this kind of bonding, or this kind of attach between two different atoms or two similar atoms, we call it a chemical bond. So we ask here a question: what is a chemical bond, or what make these two, or how these two different elements or these two atoms attach to each other? So we said that chemical bond, it is the mutual electrical attraction between the nuclei and the valence electrons of different atoms that binds the atoms together. So which means it's kind of mutual attraction. The nucleus of one atom try to attract the electrons of the outermost energy level, and the nucleus of the other atom also try to attract the electrons of the outermost energy level electrons. So somehow this kind of attraction, or this kind of force, make the two atoms bond together, or make these two atoms bend together and forming the chemical bond. So in another explanation why the bond is formed, so physically we say that an atom, once it's independent atom and just one atom alone, so we find the atom has a high potential energy. So in that case, as it has high potential, it means like the atom is nervous, it's not stable, okay? So once the chemical bond is formed, okay, we find that the potential energy in the molecule, or the potential energy of the particle, decreases, which means the atom become more stable. So here like this, that the reason, okay, why the atom try to make chemical bond. So then we pass to another type. What are different types of chemical bond that could form between two different elements, or between two different atoms? So we said that or we can say the chemical bonds could be just alternate between two major types of chemical bonds, which are covalent bond or ionic bonds. So whatever the kind of bond between two atoms, it could be ionic bond or covalent bond. What difference between ionic bond and covalent bond? Ionic bond is a kind of electric attraction that form between positive ion and negative ion. So what does it mean? As we studied in the last quarter, okay, positive ion, it usually that atoms of metals lose electrons of the outermost energy level, and they turn to positive ion, which is cation, while the non-metal atoms, they tend to gain electrons. So they gain 1, 2, or 3 electrons during chemical reaction, and they turn to be negative ion, which is anion. So simply the cation will attract the anion, because as we know, different charge, they attract each other. So the positive will attract the negative and form this kind of ionic bond. So in ionic bond, actually one atom completely give off, or they lose. That means they already one electron escaped completely from the attraction of the nucleus of this atom. So this electron comes out, okay, and pass to another atom. So one atom completely lose electron, and the other one completely gain, and that turn to positive, and the other one turn to negative. So they attract each other, like in sodium chloride, sodium Na11, so it has one electron in the outermost energy level. During chemical reaction, it loses this electron easily because it has low ionization energy. So the electron escaped, come out from the atom, and pass to the chlorine atom. Chlorine have higher electronegativity, so it will attract this electron and turn to be negative ion. So we have positive ion of sodium, negative ion of chlorine, so they attract each other and they make ionic bond, which form that table salt, or the sodium chloride, the normal salt, which we know. So that is the ionic bond. In the other hand, we have covalent bond. What is covalent? So covalent, here the word covalent, Latin word which means sharing. So covalent bond, it's a kind of bond in which the two atoms or more share in some electrons. What mean by share? That means in this case, no atom will lose, no one will gain, which means that electrons will not completely pass from one atom to another, but this electron just will be like a kind of cross point, or just going to be like corresponding between these two atoms. It will be a share. That means these two atoms, or the atoms of the molecule will share in this electron. The electrons will be counted for both. Okay, so here we said like this. Okay, covalent bond, it's a kind of bond in which the atoms share in uh, pairs of electrons. Okay, so here like this, actually once we look at two elements and we discuss if these two elements are going to combine together, they will form covalent or ionic bond or somehow like this. Okay, so actually it's hardly to decide, or actually it's not pure to say it's covalent bond, okay, or they are okay ionic bond, which means bonding between atoms of different elements is rarely purely ionic or purely covalent. That means maybe some elements, once they react with another element, sometimes they could form ionic, sometimes they could form covalent. So it depends on the pair of the elements, or depend on the two types. What are the two elements that they are going to react together? So generally, or always, we said that ionic forms between metals and non-metals, and we said that covalent bond happen between non-metals. Yes, that generally, but specifically, or when we discuss, there even sometimes a bond that form between metals and non-metals, but this bond is not ionic bond. It considered as a type of covalent bond. So how could we recognize that, or how we could decide if it's ionic bond or covalent bond? So simply that it depends on the electronegativity. Do you remember electronegativity, guys? We studied this in the last quarter. We said electronegativity is the ability of nucleus of an atom to attract the electron of the outermost energy level. So the difference in electronegativity, that the key word here, or that is the part which decide is it ionic bond or covalent bond. How we could do that? Simply, we are gonna minus, or we're gonna just subtract the electronegativity of the two elements. If the result, okay, is more than 1.7, okay, if the result is more 1.7, so it's purely ionic bond, so we can say it's ionic bond. But if the result is less than 1.7, so actually it is a covalent bond. So here again, one more time, guys. For example, here give you a example. If you say the electronegativity difference between fluorine and cesium. So if we have fluorine and cesium, they are going to react together. So the electronegativity of cesium is 4, while the electronegativity of fluorine is 0.7. So here we are going to find 4 minus 0.7. So it's equal 3.3. So the result is more than 1.7. So of course it's an ionic bond. So here like this clearly, so 1.7, that represent the part that, which means here, okay, the percentage of ionic characteristics start to be 50% starting from 1.7. So as we increase above 1.7, regarding to the scale, as you can see here, 1.7 represent 50% of the ionic characteristics. So more than 1.7 means we are gonna pass to ionic bond, and as the difference increases, okay, of course we have more ionic characteristics, which means here we find 3.3, the difference between cesium and the fluorine, okay, the lowest electronegativity and the highest electronegativity ever. So it's 3.3, so that the highest point of the scale. So we are gonna find, as we move like this, okay, we have more electronegativity, which means more ionic characteristics, okay. But if the result is less than 1.7, so it means we are gonna pass to a covalent bond. So here we find if the difference between 0 to 0.3, okay, so it's non-polar covalent bond. What meaning by non-polar covalent bond? Non-polar covalent bond, it means this actually, the difference between electronegativity between the two elements could be 0 or even slightly difference. So when it be 0, it be 0 if the two elements or the two atoms which are making the covalent bond be exactly the same. Like in hydrogen molecule, H2, oxygen, nitrogen, O2, N2. So in this, the two atoms, they are the same. So their nuclei, they have the same attraction force to the electron. So the electron of the covalent bond will be in the middle distance between the nuclei of the two atoms, because they have the same power of attraction. So they are gonna be in the middle and they spend equal time between the two atoms. So in this case, okay, there is no difference in electronegativity. The difference in electronegativity equals 0, so we call it completely non-polar. Sometimes even also if we have two elements which are closely related to, or they are closely in the electronegativity, that means they are just too close to each other in the periodic table. Like for example, the bond that could form between phosphorus and oxygen, so the electronegativity between them, okay, is not that much. So we're gonna find the electronegativity, the difference would be less than 0.3. So in this case, also still non-polar covalent bond. But if the difference of the electronegativity become more than 0.3 and less than 1.7, so in this case we decide it's a polar covalent bond. So what is meant by polar covalent bond? Polar covalent bond, it means, okay, it's a kind of covalent bond in which the electrons which are shared between the atom doesn't spend equal time between the two atoms. It actually gonna be attracted more toward one of the atom. The one which has a higher electronegativity will attract them more. Like in water, as we remember, okay, we said that water H2O. So oxygen have more electronegativity or higher electronegativity compared to the electronegativity of hydrogen. So the nucleus of oxygen is able to attract the electrons of the covalent bond more toward itself, okay? So the electrons are gonna be closer to the nucleus of the oxygen, but further from the nucleus of the hydrogen, which makes the oxygen partially negative and the hydrogen is partially positive. So here we said that there is unequal distribution of the charge. The molecule overall is neutral, but there is no equal distribution of the charge. So we call this a polar covalent bond, okay? So here like this, guys, it's simply we could find the difference, or this scale represent everything. So when he asks you what kind of bond will be found between blah, 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 whatever the elements he said, you're gonna just subtract the electronegativity of the two elements. If the difference more than 1.7, so of course it's ionic. If it's less 1.7, so of course it's covalent. So if it's more than 0.3, it's polar covalent. If it's less 0.3, so non-polar covalent, guys. That's the idea, and that's here represent the point. So let's take an example to clarify the idea here, guys. Okay, so he asks you, use the electronegativity difference and figure 2 to classify bonding between sulfur and the following elements, okay? Hydrogen, cesium, chlorine, and so like this, okay, we are gonna find. So sulfur, okay, he said that, so from figure 20, as we can see here, guys, okay, we will know that the electronegativity of sulfur is 2.5. The electronegativities of hydrogen, sodium, and chlorine respectively are 2.1, 0.7, and 3.0 or 3. So let's find here the difference between them. First of all, okay, if the sulfur again combine with hydrogen, so the difference will be 0.4. So 0.4, it's less than 1.7, so of course it's covalent, and it's more than 0.03, so it will be polar covalent, okay? And here we're gonna find the atom which is more negative, or the atom which is able to attract the electrons of the bond more, of course the sulfur, because sulfur has higher electronegativity. Here in the other one, sulfur, okay, is 2.5, cesium is 0.7. So we're gonna find that the difference electronegativity is, okay, 1.8, which means more than 1.7. So of course it's an ionic bond, okay? And because sulfur has higher electronegativity than cesium, so of course sulfur will be carry the negative charge, okay? Chlorine, okay, so chlorine here is 3, while sulfur is 2.5. So in this case, we have 0.5. So it's still a polar covalent bond. So, but actually here in this case, chlorine has a higher electronegativity than sulfur. So in that case, the chlorine, the one who will carry the partial negatively charged, while sulfur will be the partial positively charged atom, because the chlorine has a higher electronegativity than sulfur. So I hope it's clear, guys. So let's practice in this question and try to answer it together. So he said that use the electronegativity difference, okay, to classify bonding between chlorine, Cl, and the following elements: calcium, Ca, and oxygen, permine, and we're gonna find also permine. Okay, so here we're gonna find, let's find this one. Okay, so we said first one, we're gonna find the chlorine. So what is the electronegativity of chlorine? Electronegativity of chlorine is 3. So let's try to here. So 3. Hydrogen is 1. So 3 minus 1, it equals 2. Okay, so let's try to write this, guys, to make it clear. Okay, so here we said that chlorine, the electronegativity of chlorine is 3. So minus the electronegativity of hydrogen, which is 1, so it equals 2. So this 2, of course, is more than 1.7. So of course it will be ionic bond. Okay, so that because it's more than 1.7, so it is ionic. Which one will be the negative ion? Of course, chlorine will be the negative ion because chlorine, okay, have higher electronegativity, so chlorine will be the negative one, while hydrogen will be the positive one. Okay, so that's clear here, guys. Let's see, he asked about what else. Okay, so he also asks about the chlorine and so chlorine and bromine. Okay, so sorry, chlorine and oxygen first. Okay, so let's find oxygen. So actually the electronegativity of oxygen is 3.5. How we get the electronegativity? Actually, we could back to the periodic table. The periodic table already includes the value of the electronegativity of each element. So here let's find, okay, this one. We said that oxygen is 3.5, okay, minus 3, that the chlorine, so the result will be 0.5, so it is less than 1.7. So in this case, of course, it will be a covalent bond, so this one is covalent. And here in this case, we're gonna find that the oxygen has higher electronegativity than chlorine. So in this case, oxygen, the one will carry the partial negative charge, while chlorine, the one who carry the partial positive charge. Okay, so although both of them are non-metals, okay, but we could find that because this one has a higher electronegativity charge, okay, so it will they attract the electrons more toward itself, so that's why it will be okay, like that. So here, like this, guys, that's the idea, or that's how we could answer a question like that. I hope it's easy for you, and I hope that you could figure how you could decide the difference between the ionic and the covalent bond. So please, guys, okay, your homework, or your first homework, will be answering the section review, okay, page 177. Next time, inshallah, we're going to discuss it together. Thank you, guys. Please study well, and if you have any question, you can ask me. Thank you, guys. Goodbye.